This video will cover section 2.1, and this is the last part of 2.1, and it'll be on graphing the equations we've already found the solutions for. So when you find the solutions to all of these equations, they give you points that you can plot within the coordinate plane and connect to make a graph. Alright, so all these three equations that are on this page, we have already found the solutions for them. So back in the previous video, we were looking at the solutions. We found the solutions for y equals negative 2x plus 5 to be 0, 5, 1, 3, and 2, 1. So we found all three of those solutions by plugging in our points and solving for the other, plugging in for one specific variable and solving for the remaining one. Alright, so I want to put these points on this coordinate system. So remember, the axis that runs horizontally, left to right, is the x-axis. And then the axis that runs vertically or up and down is my y-axis. Now these points here, the first one is your x value and the second one is your y value. So just like the axis runs left to right for x, these numbers tell us left or right how far to go. Positive goes right, negative goes left. Same for the y. Because the axis runs up and down, my y values tell me how far up or down to move. I'm going to make two movements to get to one location. I'm going to go left or right and up or down to get to one point. So to get to the point 0, 5, always starting at the origin, which is where the two axes cross, this is 0, 0. I'm going to start here, looking at the first point. Alright, it tells me don't go left or right any, but go up 5. Alright, and I'm going to put my dot there. Then I want to go, for the second point, back to the origin. It tells me to go right 1, and then up 3. And put my dot. And then lastly, back to the origin, it tells me to go right 2 and up 1. I'm going to put my dot there. Alright, now I want to connect these three dots. Remember, this is a linear equation, so when we connect the dots, it should form a straight line. And when you're plotting your points, you should see the line starting to form, okay, with your dots before you ever even connect them. Once you do connect them, make sure you go all the way through the points, arrows on each end, because this line goes on forever. There are an infinite number of possibilities we could fill in. We just are limited in our graph and paper size. Okay? Now, let's look back. Alright, and for the square root, our solutions we found were 5, 0, 6, 1, and 9, 2. So I want to plot these points here, 5, 0, 6, 1, and 9, 2. Now if you look back in your packet on the previous page, alright, are these parent functions. Alright, these are the basic of each type of equation and what their graphs look like. So for square root, alright, the square root of x, its graph has this basic shape. And so no matter what we have under this square root sign, our graph should have this basic shape. It may shift left or right or maybe up or down, whatever our equation may be, but still maintains its shape. Same for linear, always a straight line. It may rotate around to where it's not going from bottom left to upper right, but from top left to bottom right, and shift up and down. Alright, quadratics always have this basic shape here, the parabola shape. It may shift left or right, shift up or down. It may widen, it may shrink in size, but always this basic shape. Okay, so keep that in mind. Make sure that when I call out an equation, you know in your mind what the shape of that equation should be. Therefore, you'll know how to connect the dots. Alright, so we know our points. Let's plot them. So from the origin, I'm going to go right 5 and none up or down. So put me a dot. Alright, from my origin, I'm going to go right 6 and up 1. And from my origin, I'm going to go right 9 and up 2. Then I will connect my dots, making that basic curve shape. Alright, for our parabola, our points we found were 0, 1, negative 1, 2, negative 2, 5, and then 1, 2, and 2, 5. Okay, so this is our vertex. It should be the lowest point on our graph. So I'm going to graph it first. Here's 0, 1. Now all these other points, if I have correctly filled in and solved for y, or if I plot correctly, all these points should be above my vertex, 0, 1. If you have any that are below, alright, then you know somewhere something went wrong. Either you plotted it incorrectly or you have done your math incorrectly. Okay, so let's plot the other points. I'm going to plot negative 1, 2. So left 1 and up 2. Alright, the point that matches it is 1, 2. So from the origin, I'm going to go right 1 and up 2. Alright, so recall that right through the middle of the vertex is an imaginary line, the axis of symmetry. All of these points, alright, should be, the pair should be equal distance from that axis of symmetry. So if I'm looking at this point and I move 1 to hit the axis of symmetry, I should be able to move 1 more to the right and encounter my next point. They're the same distance from that axis of symmetry. Alright, same thing with negative 2, 5 and 2, 5. If I move left 2 and up 5, if I count the distance to my axis of symmetry is 1, 2. If I continue that same distance, 1, 2, I should then have another point. Alright, and we've said that point is 2, 5, so right 2 and up 5 is that point. You see how they match up? Alright, you can also plot your points that way. Or you could just say right 2, up 5, left 2, up 5, and you can kind of see how they're equal distance from the axis of symmetry. Then I'm going to connect my dots in the parabola shape, put arrows at each end because remember it continues on in the upward direction. There are plenty of numbers to the left and right of that vertex that we could have filled in.